You need beads, or more specifically, your agents need beads. Most people create a code base or a SaaS product by telling Claude Code or Codex what to do, or by giving it a plan file and telling it to follow the plan and execute on it. But that actually isn't enough for these coding agents. They need beads because beads take that big plan and turn it into actionable tasks that the coding agent can execute. Welcome to episode 3 of Agentic Engineering with parallel agent swarms. In this episode, we're going to cover beads. So here's what you're going to learn. We're going to learn what are beads. What are they? We're going to learn how they fit into the agentic engineering workflow that you've seen in the previous episode. Finally, I'm going to show you how to turn the plan document that we created in the previous episode into a set of actionable beads that a swarm can attack. So let's get right into it. What are beads? Well, beads are an interdependent network of tasks. That's all they are. The term was coined by Steve Yege in 2025. He's the creator of Gastown, and he's the first person that created a bead software. The network of beads exhibits a directed acyclic graph structure. Now, I know what you're thinking. The slides are getting boring. So let's get to the cool visual that ChatGPT created. ChatGPT is getting way better at images. So this explains it perfectly, actually. What is a bead? Well, it has IDs, it has titles, it has the type, priority status, labels, dependencies. Now, if you are a software engineer by trade, you recognize this structure as a Jira ticket or a story, right? It has the same exact structure, except it's designed for agents. So it exhibits a directed acyclic graph structure. So here's an example, right? We have like a launch feature, design API, define schema, plan UI. This is actually a great example of what a bead graph would look like, right? It has the priorities as well. Then it has relationship types, blocks, parent-child, right? And Epic has a bunch of subtasks. This is the same way that it is in Jira, but beads are basically just a Jira ticket for your agents, right? Blocks are very important because they ensure that the agent doesn't execute beads that are not ready to be worked on. And so this is how beads usually go. They're created, the dependencies are added later, and then once they're done, right, the agents can then run a command like BD ready to see which beads are ready to be worked on. They'll claim work, they'll execute on the work, and then they'll finally push it to main. So that was all a little fast, I know. And this stuff looks really complicated. So let's simplify it. What is a DAG, right? You're probably thinking, what is a DAG? I have this very simple illustration here for you. Doesn't that look nice? All right, so this is what a DAG is. It's a directed acyclic graph. Directed because it follows the arrows. And it's acyclic because by following the arrows, you can't form a cycle or a loop that never ends. You don't want that when you have beads. You want it to eventually finish. And so here's an example of a simple directed acyclic graph. Here is an example of a simple cyclic graph because it'll just go in a circle here. Does that make sense? Great. So now that we understand DAG and we understand kind of what beads are, how do they fit into the agentic engineering workflow? Well, they come right after the plan step. Planning is 80% of the work, and it's the most important part. If you haven't seen that video, go check it out. Beads take the plan and break it up into actionable tasks. A plan document is designed to fit into the context window of an LLM so that an LLM can see the big picture and reason over it. Whereas beads, or a bead graph, is designed to be readable by an agent swarm. It's designed for an agent swarm to be able to attack it. Individual beads are designed for individual agents to be able to execute on. And so it keeps things really, really organized, as opposed to having an agent swarm or even one agent try to execute a plan document. It might put the cart before the horse. The reason that beads exhibit this directed acyclic graph is because that way it makes sure that the cart does not go before the horse. Let's say it needs to execute the light bulb task before the book task. Well, that's where this dependency comes in. If you give an agent a plan document, it might take that light bulb feature and put it before the book feature. So that's why this directed acyclic graph structure is very important for beads. In addition to that, they also contain more information than the plan document because they track work, right? So going back to this visual, it has the status, right? And that's very important. A bead being open means it hasn't been worked on. A bead that is in progress means that they shouldn't touch it because it's in progress. That also means they shouldn't touch any beads that depends on because it's in progress, it's not done. Done means that they can go work on beads that depend on that done bead. And then blocked finally means that they shouldn't touch it because there are other beads that haven't been worked on yet that they shouldn't touch, right? So you see how this keeps everything organized. You can think of beads or a bead graph as like the project management layer. It makes sure that the swarm maintains its cohesion. It basically keeps the swarm organized. And so you might not be surprised to see that swarm, setting the agent swarm off on the bead graph, is what comes directly after that step. All right, now you understand the what. Now let's get into the how. And so I have this plan document where I am going to create my own version of OpenClaw, but I'm planning on making it more sandboxed, more secure, and I'm going to be writing it in Rust. So here's phase one of my personal AI assistant, and I'm going to download this plan document. I use the exact same method that I talked about in my previous video. Then I'm going to go to GitHub and create a new repository, right? We're going to call this, I'm going to create my own assistant, so I could call it Ironclaw instead of OpenClaw, although that doesn't really work because there's already an Ironclaw that's written in Rust that basically is claiming to do what I'm wanting to do as well. Although they're tied to a specific vendor, there's reasons that I don't want to copy them. Or I could name it something cool like Romulus. Actually, I think I'm going to go with Romulus because why not? I think it's cool. All right, and we're going to make this private for now because I don't want people forking this at the moment. Especially if I'm worried about security, I don't exactly want people to know how my agent is made, but I might change that later. Anyways, also side note, if you're creating a new repository in GitHub, always default to private. You can make it public later, but if you're creating something new, just default it to private and change it later if you want. All right, so it is created, and the first thing we're going to do is we are going to upload the plan document to it. So we have this button here, create an existing file, choose files, and we're going to upload it. And I'm also going to upload the overarching plan for this thing. Right. Then we're going to commit changes to make sure that these are tracked. We have a repo called Romulus. We have these two plans here, the overarching plan and phase one. And phase one is the one that I'm going to be turning into beads. So now I'm going to log into my VPS and spin up the Flywheel. And so if you haven't seen my other videos, I use the Agent Flywheel ecosystem by Jeffrey Emanuel to do all of my agentic coding. It's the most complete system that I've seen out there, and so that's why I use it. Jeffrey created his own version of Beads called Bead Rust, and he forked it over from Steve Yeager. You definitely should check out this website. Go to it. It has all the instructions as to what all of these tools do. So I have this command here, which is basically a bootstrap that runs a bunch of other commands. Just know that it initializes the NTM workspace. NTM is the control panel for the Flywheel, and it pulls from GitHub, so it'll pull those documents that we want, and it'll specify what the plan document is. You don't have to memorize all that. So let's make sure that that command actually worked. ls, and we can see that it initialized agents.md, and it has both the plan documents. So this is exactly what we want. Now I'm going to go to Jeffrey's website, and I'm going to steal this prompt that he gave us, and I'm going to paste it in here. So I just modified his prompt a little bit to say, instead of take all of that, which is vague, read all of this file and elaborate on it more, and then create a comprehensive and granular set of beads for all of this with tasks, subtasks, dependencies, blah, blah, blah. Now, you might be wondering, wait, what does that actually do? We're asking the agent to create beads for us? Well, yeah, actually, that's exactly what we're doing. And the reason we're doing that is because the agent is really good at creating beads. Jeffrey designed this BR tool to be used by the agents, not by human beings. Because let's be real, the whole shift from coding to agentic engineering is to have the agents do the work for you. And that applies to everything, not just the code base, but also the beads. So while we're waiting on that, there's a really handy thing that Codex has where you can put in a prompt right here, copy paste it, and then you hit tab. Once it's done with whatever it's working on, that prompt is going to get injected into the pane, and it's going to work on whatever you put in next. So once it's done creating the beads, I have this prompt here where it's like read the agents.md and review each bead and see if it can be improved. I have a few more prompts like that. So if you want, you can pause the video and just read through all these prompts. This is one that I got from his website. You can get that from there. This is my own prompt, also my own prompt about stepping back and looking into the future. That one's really helpful. And then this one to make sure everything is super clear. So if you want, pause the video and take a look at these. So here's how you automate the bead creation is you just keep pasting in some of these prompts. So I can go here, paste tab. Let's see, after that, I'll have it read this guy again. All right. And so we'll have it do this one again. And then we'll have it peer into the future, have a few of these, one last future prompt, one last review beads prompt, and then finally, is each bead super clear for what it is and what success looks like? Okay, so we've queued up like 13 or so prompts, 14, 15. I have no idea. I wasn't counting. But point is, we just keep having the model look over its beads again, check back with the plan, look and try to see if there's any future problems that could arise from this architecture. Is each bead super clear? And by doing that, we get it to kind of look at it in different ways and check itself multiple times. And what we can do now is basically just walk away, come back in a couple hours, and the beads will be all done. Trust me, I've tried doing this manually too. By having these different prompts and layering them after each other and feathering them back and forth, you actually do get a really good thing going. And so that's basically it. Once we come back, I'm really just going to show you the beads that got created, and they'll be done and ready to execute. This is why I said that beads are only 2% of the actual effort, because once the plan is in place, it's very easy to create the beads from that plan. So just to give you an idea, we're about an hour and a half into the agent going through and executing on those prompts that we queued. We have this handy command here named brstats, which basically lets you look at the beads. And so we can see that there's 146 open beads, and out of those 146, 140 are blocked. So that means that if the agents were to execute right now, they could do 6. There are 6 that they could pick from. Now, this is going to keep changing. As you could see, I checked earlier and there were 134. Now there's 146. Generally, as it keeps refining, it will split the beads more and more or add more. If there are any missing ones, it'll add ones for testing. And so you're going to notice if you keep checking with this command that the beads will slowly grow as it follows your prompts. Now, that's kind of a good thing. You want to err on the side of more beads because, number one, you want the beads to be granular. You want them to be small because otherwise, if you end up making meteor beads, then the agents have to do a whole lot more work per bead. You want the beads to be small enough that they're granular and that the agent can just execute them very easily. The advantage of smaller beads too is that it relies less on the intelligence of the agent. So if you have beads where the tasks are smaller, then the LLM behind the agent doesn't need to be as smart. So if you're into self-hosted LLMs, which tend to be not as smart as the frontier models, then this is really helpful. If you do use frontier LLMs like GPT 5.5 and Opus 4.7, those are the 2 newest right now. I know that'll change in like a month. Anyway, these beads kind of make that foolproof because you're using a model that's way too smart for the task. And so it's very, very unlikely that they make mistakes with that. Whereas it's a lot more likely if you give them larger tasks to bite off of. So it ended up taking around 3.5 hours. The amount of time it takes for an agent to create beads will vary based on how many prompts you have, how many beads it produces. If it produces more beads because there's more to do, then it'll take longer to check, right? Because if it has to check over every bead and there's more beads, then that's how it is. But just taking a look right here, we got 152 beads. 132 of those are blocked. So that's not too bad. So we're going to do BR graph all. So you're probably like, whoa, like what is all this stuff? Well, these are all the beads, right? This is what they're named, and then this is their priority, whether they're open, closed, whatever, and this is kind of all of them. So that's kind of a cool view. If you want an even cooler view, Jeffrey created this tool called Bead Viewer. So we go BV and boom, we get this terminal UI that shows us all the beads and we can kind of scroll down and look. So here's an example of one bead. It says define deterministic timestamp and duration semantics for evidence, right? Priority, hot, spicy, hot. I don't know what that means. Okay. I actually don't know what that's short for. Anyway, yeah, you can see how it has, impact depth, centrality, flow role. So it has all of these things that the agent can use. Not to mention, last but not least, the description. So it says define phase 1 of the time contract for audit events. So you see how granular this particular bead is, and they're all going to be like this, right? And so you can kind of see how powerful it is. it has the prompt, it has the dependency, it has all this information, and it's all trackable. You can see how this can really make the agent swarm organized. And it's a lot more organized than trying to set off an agent or a swarm on a plan document. You see how that works? Let's look at another, all right? We got status, priority, hot again. That thing, impact depth is 9. Description, define and verify the behavior for interrupted phase 1 commands, timeout paths, and partially written evidence. This covers Control C. Now, if you don't understand what this is saying, that's actually okay. Number one, you didn't go through the plan like I did. Like, I created this plan, so I do have an idea of what's going on here. You didn't, so you're not supposed to know, right? You weren't following along. That's fine. And secondly, if I don't know exactly what this is saying, that's actually also okay, because these beads are not meant to be read by humans. They're meant to be read by agents. And so all that matters is that it makes sense for the agent, not the human being like myself. The plan document, by contrast, you do want to be readable by a person, and you do want to kind of understand what's going on in that plan document. At the bead level, things get more granular. It starts talking about exactly how it's going to implement, this coding strategy. Some of the beads even have pseudocode in them that specifies what it wants the agent to do. So just keep that in mind. If you do go through these beads, don't feel bad if you don't understand what's going on. It's just kind of a cool thing to look through and be like, okay, kind of skim it. You know what I mean? So yeah, this is cool, right? This is really cool. I think it is, because we started out with a plan. That's it, just like a plan document that we created, albeit a detailed one. And now we've taken it to this interconnected dependency graph with all this information and tracking and stuff that can tell the agents exactly what they need to do. And not only that, because of how this tool was set up and, how good AI agents are, the prompts that we put into the pane and queued up, we were able to do this with very minimal effort. So now you can really see and believe that the beads portion is 2 or 3% of the work, because it's really not that much work at all. And it derives it directly from the plan document. So another thing that I want to show you is if we go to the GitHub repo, here's what beads look like in the actual repository. It creates a .beads folder. And then what we really want to look at is issues.jsonl. That's where the beads are stored. This has 152 lines, 1 bead per line, and you can see exactly what the beads have. So you can see the title right here, the description, and it is really hard to read in this format, which is why if you actually want to view the beads in the description, you would use the bead viewer tool. But I think it's cool to look at the beads in their raw form and see where they are, just in case you're wondering, what happened to my beads or something like that. It's stored in GitHub and version controlled, and it's not in the git ignore. And I think that's a really good way to do it, because that way you can track what happened to the beads, what was used. And actually, this is just a prediction of mine, but I'm thinking that in the future, people will, instead of sharing code, you could share beads, and people could rebuild things from the beads. I don't know if that's exactly the way it'll go, but it's certainly a possibility and something that I've thought about, just taking the beads, tweaking the beads, and then building something that somebody's already built, like Jeffrey, for example. If I wanted to clone one of his repos and modify it, I might actually start with the beads and modify the beads first and then build from there, as opposed to trying to start from the plan phase, using his repo as a reference and then tweaking the plan and stuff. It might just be more efficient to start with the beads that he has in his open source software. But that's it, guys. That's all. We covered everything. We covered what a bead is, we covered what a DAG is and how that works and why it's a DAG and why it has all these dependencies and why it's better than using a plan document. And then after we covered the why and the what, we covered the how. I showed you exactly how to create beads from a plan document. It was super simple, super easy, and it really makes a big difference when it comes to creating high quality software with coding agents. So the next video is going to be the fun stuff, where we actually set the swarm off on the beads that we created in this video. So stay tuned for that, and happy coding.